Morning, everyone. So today we're going to continue our lesson on natural selection, but today we're going to learn about something called alleles and allele frequency and how to calculate allele frequency. And it looks complicated, but when you see it, it's actually very simple. Remember when we talked about dominant? The big letter is the dominant one, the stronger one, and that's why when you have two, the dominant, for example, here is the big one is purple, and the recessive one is recessive means the weaker one is the white allele. Okay, so this is dominant, this is recessive. I'm gonna write it down. Okay, the dominant is the strong one and the recessive is the weak one. So if you have the dominant is purple, so if you have two big B's, it'll be purple. If you have one big B, one small b, it'll still be purple because big B is weak one, it's strong. It's a dominant one. And if you have two small b's, it'll be the white one. Okay, and that's dominant and recessive. We have to learn what genotype is. Genotype is this, the BB genetic code, which is the BB or big B small b, or big B small b. And the phenotype is the shape. For example, here the phenotype is purple, here it's purple, and here it's white. So that's the difference between genotype and phenotype, but that's not what we need to focus on right now. We need to focus on something called calculating allele frequencies. Let's go ahead and go there. So an allele frequency is a measurement of how common a trait is in a population. For example, the trait here, الصفة يعني, the trait here is the color of the flower. That's the trait here. Okay, so how common is the purple here? If you notice, purple here is more common because purple is dominant. But let's see. Okay, let's see how do we calculate the allele frequency. Frequency is a measure of how common something is. Okay, so an allele frequency is how common the trait is, how common the allele is, because we talked about these are called alleles, WW. Okay, these are called alleles and how common they are. And why are we studying this? Because in natural selection, okay, this can be a dominant, like the purple flower. Okay, after a while, nature might select the white flower to survive because of some certain environmental things that are happening. Okay, and then you might find more white flowers later. Okay, but let's just see how to calculate allele frequency now. So you have to calculate the frequency of the big W in each, like when I give you to calculate allele frequency, I always tell you, for example, here that it will be to calculate the allele frequency of the big W and the allele frequency of the small w. Okay, so of the dominant and of the recessive. Let's see how to do that. So how do you do the allele frequency of the big W? You do it this way. You count how many alleles do you have. Like, let's say count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So I'm going to write here the total equals to 18. Now I will count how many big ones, how many dominant ones, how many capital W. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I have big W 13. So what do you do is the number of big W divided by the total. So number of big W is 13, like we did it, divided by big W, which is 18. Okay, and then you use a calculator and the answer is 0.72. So the allele frequency of the big W is 0.72. Okay, let's see the small w. Small w is also the same, the number of small w divided by the total. Okay, so what's the number of small w? We have to count 1, 2, 3, 4, 5. Only 5 we have. So 5 divided by 18, and then use a calculator, is 0.28. If you notice, 0.28, these two need to be equal to 1 together. Okay, if you use a calculator and you add 0.72 plus 0.28, they will be equal to 1, because this is like the total of everything. But now when we look at this, which has more allele frequency? The big W. Okay, look, the big W has a higher frequency. Okay, the small w has a lower frequency. If you can see this, big W has 0.72, small w has 0.78. So who has a higher frequency? Big W. If you notice here and you look at the population, yes, big W has a higher frequency because there's more purple flowers. Look, there's 1, 2, 3, 4, 5, 6, 7 purple flowers, only 2 white flowers. Okay, so the allele frequency shows that the purple flowers are more than the white flowers. Okay, now if we look here, there's another one. There's 2 generations. There's an original generation and then the generation after natural selection. Okay, a new generation. So this is how scientists study natural selection. They check allele frequency. So what's happening? Let's see. And this one, this is the same. The original generation is the same as this. Okay, same one as the one before. So we already counted. So it's 13 divided by 18 and 5 divided by 18. Okay, let's do the new generation. In the new generation, we have to count the big W's. We have to count the total first. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So the total equals to 18. And then we count the big W. We count the capital W, the dominant trait. 1, big W, 2, 3, 4, 5, 6, 7, 8. So we have 8. So if you've noticed here, allele frequency of the big W, this is how you can write it, equals to 8 divided by 18. Okay? Because it is equal to the number of how many times you see the big W and divided by the total, which is, you use a calculator, it's 0.44. Okay, and then you check allele W, the small one. How many small ones do we have? Let's count. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 small W's. So 10 divided by the total, which is 18. And then we use a calculator, and the number is 0.56. Okay, now the question here is, what changed between the original generation and then later in the new generation? Okay, if you notice, the allele frequency, which is of the big W, has become less, and the allele frequency of the small w, look, has become more. It used to be 0.28, now it's 0.56. It has become a lot more. Okay, and the other one, the big one, has become a lot less. So the frequency of the dominant allele has decreased. This is the dominant allele. It has decreased from here to here. And the frequency of the recessive gene or the recessive allele has increased. Look at this, from here to here. It has increased in the new generation. This is due to natural selection. So this is how this is related to natural selection. Because of natural selection, you will notice that more white flowers are forming in the new generation. Maybe because there is some predator that eats the purple ones. Maybe, I don't know. There's a lot of reasons that can cause flowers in the new generation to be more white. Okay, maybe according to weather conditions, the white ones are able to survive better now. You never know what's the condition that's going on, but they're just showing you here an example that in the original generation you had more purple, in the new generation there is more white, and the alleles are changing completely, and the dominant allele has become less, the recessive allele has become more. Okay, that's how you calculate allele frequency. We will take the next part of the lesson in the next video.